In a residential electrical panel, the ground and neutral conductors are typically connected to the same bus bar. This is a code requirement according to the National Electrical Code. The connection of ground and neutral conductors serves several important purposes. Firstly, safety. By connecting the ground and neutral together, it ensures that there is no voltage difference between the two conductors. This reduces the risk of electric shock if a person accidentally comes into contact with both conductors. Secondly, the neutral wire provides a return path for electrical current back to the electrical source. The ground wire, on the other hand, provides a safety path for fault currents to flow to ground in the event of a short circuit. Thirdly, connecting the ground and neutral to the same bus bar simplifies the wiring process and reduces the number of wires that need to be connected. In certain specific cases, such as in subhulls or for specific equipment, the ground and neutral terminals may be separated. However, this is uncommon and requires special permission from the local electrical inspector. In a residential electrical panel, the ground and neutral conductors are required to be connected to the same bus bar. This is a safety requirement that ensures the proper functioning of the electrical system and minimizes the risk of electric shock. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It covers various aspects of electrical wiring, equipment, and systems, including the grounding and bonding requirements. Proper grounding and bonding are crucial for electrical safety as they provide a low-impedance path for fault currents to flow back to the source, which helps to trip over current protection devices like circuit breakers or fuses. This rapid disconnection of the circuit minimizes the risk of electrical shock or fire. In a typical residential electrical service, the neutral conductor is grounded at the service entrance. This means that the neutral conductor is physically connected to the earth, usually through a grounding electrode system. This grounding electrode system can consist of things like ground rods, ground plates, or the metal frame of the building if it's effectively grounded. The purpose of grounding the neutral is to establish a common reference point for the electrical system and to limit the voltage between the neutral conductor and the earth. When the ground and neutral are connected at the main panel, all metallic enclosures of electrical equipment, such as appliance chassis, metal conduit, and junction boxes, are bonded to the grounding system. Bonding ensures that these metallic parts are at the same potential as the ground, minimizing the risk of electric shock if a fault occurs. For example, if a hot wire accidentally comes into contact with the metal casing of a washing machine, the fault current will flow through the grounding system back to the source, tripping the circuit breaker and cutting off the power. Without proper grounding and bonding, the metal casing could become energized, posing a serious shock hazard. Subpanels, which are additional electrical panels located downstream from the main panel, have different grounding and neutral requirements. In a subpanel, the neutral conductor must be kept separate from the ground conductor. The neutral bus bar in the subpanel should not be bonded to the subpanel enclosure. Instead, a separate grounding conductor must be run from the subpanel back to the main panel and connected to the main panel's grounding bus bar. This separation of the neutral and grounding subpanels is intended to prevent neutral current from flowing through the grounding conductors, which can cause unwanted voltage drops and create a potential safety hazard. The reason for this difference in the main panel versus subpanel wiring configuration is to prevent parallel neutral current paths. In the main panel, the neutral is intentionally bonded to ground, establishing a single point where the neutral and ground are connected. This ensures that any fault current has a clear and direct path back to the source. However, if subpanels were also bonded in this way, it would create multiple parallel paths for the neutral current, which can lead to circulating currents and voltage imbalances. These circulating currents can cause the metal enclosures of electrical equipment to become energized, potentially creating a shock hazard. By keeping the neutral and ground separate in subpanels, you ensure that the neutral current only flows through the neutral conductor, and the grounding conductor only carries fault current. This helps to maintain a safe and reliable electrical system. There are a few specific exceptions to the general rule of connecting the ground and neutral at the main panel. One exception is for certain types of equipment, such as generators or separately derived systems. In these cases, the neutral may need to be grounded at the source of the power rather than at the main panel. Another exception is for specific types of circuits, such as isolated ground circuits, which are used in sensitive electronic equipment to minimize electrical noise. Isolated ground circuits have a separate grounding conductor that is isolated from the regular grounding system. This helps to prevent noise from other electrical equipment from interfering with the sensitive equipment. It's important to always consult the NEC and local electrical codes for specific requirements and guidelines. The NEC is updated every 3 years, so it's important to stay up to date on the latest changes. Additionally, local electrical codes may have additional requirements or restrictions that you need to follow. When working with electrical wiring, it's always best to consult with a qualified electrician to ensure that the work is done safely and correctly. The electricity can be dangerous, and it's important to take all necessary precautions to avoid electrical shock or fire. Some additional considerations related to grounding and bonding include the size of the grounding conductors. The NEC specifies the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. The grounding conductor must be large enough to safely carry the maximum fault current that could flow in the event of a short circuit. The type of grounding electrode used is also important. Ground rods are the most common type of grounding electrode, but other types of electrodes, such as ground plates or the metal frame of the building, may be used in certain situations. The grounding electrode must be installed in accordance with the NEC requirements to ensure that it provides an effective ground connection. The location of the grounding electrode is also important. The grounding electrode should be located as close as possible to the electrical service entrance. This helps to minimize the impedance of the grounding path and ensure that fault currents can flow quickly and easily back to the source. Regular inspections of the grounding system are also important. The grounding system should be inspected periodically to ensure that it is in good condition and that all connections are tight and corrosion-free. Any damaged or corroded component should be replaced immediately. Another aspect of grounding is equipotential bonding. Equipotential bonding involves connecting all metallic parts within a specific area to the same electrical potential. This is commonly done in swimming pools, spas, and other areas where water is present. The purpose of equipotential bonding is to minimize the risk of electric shock by ensuring that there are no voltage differences between different metallic parts. This helps to prevent current from flowing through a person's body if they come into contact with two different metallic parts. Surge protection is another important aspect of electrical safety. Surge protectors are devices that protect electrical equipment from voltage surges or spikes. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting the excess voltage to ground, protecting the equipment from damage. There are different types of surge protectors available, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the electrical service entrance and protect all of the electrical equipment in a house. Point-of-view surge protectors are plugged into individual outlets and protect the equipment plugged into those outlets. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect people from electrical shock by monitoring the current flowing in a circuit. If the GFCI detects a difference in current between the hot and neutral wires, it will quickly trip the circuit, cutting off the power. GFCIs are commonly used in bathrooms, kitchens, and other areas where water is present. They are also required by the NEC in certain locations. Arc fault circuit interrupters, or FSIs, are another type of safety device. FSIs are designed to protect against electrical fires by detecting arc faults. Arc faults are dangerous electrical discharges that can occur when wires become damaged or loose. FSIs work by monitoring the electrical current in the circuit and detecting the unique characteristics of arc faults. When an arc fault is detected, the FSI will quickly trip the circuit, cutting off the power and preventing a fire. The NEC requires FSIs in many areas of the home, including bedrooms, living rooms, and dining rooms. When working with aluminum wiring, special precautions need to be taken. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. However, aluminum wiring can be more prone to problems than copper wiring. Aluminum wiring can corrode over time, which can lead to loose connections and overheating. To prevent problems with aluminum wiring, it's important to use special connectors and devices that are designed for use with aluminum wiring. It's also important to have the wiring inspected regularly by a qualified electrician. In addition to the NEC, there are other standards and organizations that provide guidance on electrical safety. Underwriters Laboratories, or UL, is an independent organization that tests and certifies electrical product. UL-listed products have been tested and found to meet certain safety standards. The National Fire Protection Association, or NFPA, is another organization that provides guidance on electrical safety. The NFPA publishes the NEC, as well as other standards and guidelines for fire safety. The Occupational Safety and Health Administration, or OSHA, is a government agency that sets and enforces workplace safety standards. OSHA has regulations related to electrical safety that employers must follow. Electrical safety is a complex and important topic. It's important to understand the basics of electrical safety and to take all necessary precautions to avoid electrical shock or fire. Consulting with a qualified electrician is always the best way to ensure that electrical work is done safely and correctly. When troubleshooting electrical problems, it's important to follow a systematic approach. Firstly, start by identifying the problem. What is not working correctly? Secondly, check the circuit breaker or fuse. Is it tripped or blown? Thirdly, use a multimeter to test the voltage and continuity of the circuit. Is there power to the circuit? Is there a break in the wiring? Fourthly, inspect the wiring for any signs of damage or corrosion. Are there any loose connections? Fifthly, test the components of the circuit. Are the switches, outlets, and appliances working correctly? Sixthly, consult with a qualified electrician if you are unable to resolve the problem. Color coding of electrical wires is also important for safety. In the United States, the standard color code for electrical wiring is as follows. Black wires are typically used for hot wires. Red wires are also sometimes used for hot wires. White wires are typically used for neutral wires. Cream wires are typically used for ground wires. Bare copper wires are also used for ground wires. The use of proper color coding helps to prevent confusion and makes it easier to identify the different wires in a circuit. It's important to always follow the color code when working with electrical wiring. Electrical panels should be properly labeled. Each circuit breaker or fuse should be clearly labeled to indicate what it controls. This makes it easier to identify the correct circuit to turn off when working on electrical wiring. It also helps to prevent accidental shutoffs of important circuits. Electrical panels should also be kept clean and free of clutter. Tools, equipment, and other items should not be stored inside the electrical panel. This can create a fire hazard and make it difficult to access the circuit breakers or fuses in an emergency. The area around the electrical panel should also be kept clear to allow for easy access. The working space around electrical equipment is crucial for safety. The NEC specifies the minimum working space that must be maintained around electrical equipment, such as electrical panels, transformers, and switchgear. The working space must be large enough to allow electricians to safely access and work on the equipment. The working space must also be kept clear of obstructions. Proper ventilation is also important for electrical equipment. Electrical equipment can generate heat, and proper ventilation is needed to prevent overheating. Overheating can damage the equipment and create a fire hazard. Electrical rooms should be well ventilated to allow for the free flow of air. Ventilation openings should be kept clear of obstructions. Periodic maintenance of electrical equipment is essential for ensuring its safe and reliable operation. Electrical equipment should be inspected regularly for any signs of damage or wear. Loose connections, corroded wires, and damaged components should be repaired or replaced promptly. Electrical equipment should also be cleaned regularly to remove dust and dirt. Transformers are important components of electrical systems. Transformers are used to step up or step down voltage levels. Transformers consist of two or more coils of wire wound around a common core. The voltage ratio between the primary and secondary windings is determined by the number of turns of wire in each winding. Transformers are used in a variety of applications, including power distribution, lighting, and electronic equipment. Generators are used to generate electricity. Generators convert mechanical energy into electrical energy. Generators consist of a rotor and a stator. The rotor is a rotating component that contains a set of windings. The stator is a stationary component that also contains a set of windings. When the rotor is rotated, it creates a magnetic field that induces a voltage in the stator windings. Generators are used in a variety of applications, including power plants, emergency backup systems, and portable power sources. Motors are used to convert electrical energy into mechanical energy. Motors consist of a rotor and a stator. The rotor is a rotating component that contains a set of windings. The stator is a stationary component that also contains a set of windings. When electrical current is applied to the stator windings, it creates a magnetic field that interacts with the magnetic field of the rotor, causing the rotor to rotate. Motors are used in a variety of applications, including appliances, tools, and industrial equipment. Capacitors are used to store electrical energy. Capacitors consist of two conductive plates separated by an insulating material. When a voltage is applied to the plates, electrical charge accumulates on the plates, storing energy. Capacitors are used in a variety of applications, including power supplies, filters, and energy storage systems. Inductors are used to store energy in a magnetic field. Inductors consist of a coil of wire. When electrical current flows through the coil, it creates a magnetic field. The energy is stored in the magnetic field. Inductors are used in a variety of applications, including filters, energy storage systems, and transformers. Resistors are used to limit the flow of electrical current. Resistors are made of a material that resists the flow of electricity. The amount of resistance is measured in ohms. Resistors are used in a variety of applications, including voltage dividers, current limiters, and pull-up resistors. Diodes are semiconductor devices that allow current to flow in only one direction. Diodes are used in a variety of applications, including rectifiers, switches, and voltage regulators. Transistors are semiconductor devices that can be used to amplify or switch electronic signals. Transistors are used in a variety of applications, including amplifiers, oscillators, and digital circuits. Integrated circuits, or ICs, are complex electronic circuits that are fabricated on a single silicon chip. IC contain millions or even billions of transistors, diodes, resistors, and capacitors. IC are used in a variety of applications, including computers, smartphones, and electronic appliances. Programmable logic controllers, or PLCs, are used to automate industrial processes. PLC are computers that are specifically designed for use in industrial environments. PLC can be programmed to control a wide variety of industrial equipment such as motors, valves, and sensors. Variable frequency drives, or VFDs, are used to control the speed of electric motors. VFD work by varying the frequency of the electrical power supplied to the motor. VFD can be used to improve energy efficiency, reduce wear and tear on equipment, and improve process control. Uninterruptible power supplies, or UPSs, are used to provide backup power in the event of a power outage. UPS contain batteries that can supply power to critical equipment for a limited time. UPS are used in a variety of applications, including computers, servers, and medical equipment. Electrical codes and standards are constantly evolving to keep up with new technologies and to improve electrical safety. It's important to stay up to date on the latest codes and standards to ensure that electrical work is done safely and correctly. Consulting with a qualified electrician is always the best way to ensure that electrical work is done safely and correctly.